Hi, welcome. We all need to wake up, do a little stretch. Thank you all. I hope you've enjoyed your MarkLogic world so far. Now we have a little more exciting stuff. We've got security, which is super exciting. I told you before. You know what's exciting? When things aren't secure, then we're sad. So, right? Housekeeping, I'm sure by now you've all heard this a bunch. Cell phones off, right? And there's the next question. Has anybody downloaded the MarkLogic World app? Yeah? What should we do with the MarkLogic World app? Fill out the survey. Good. Okay. We're also going to record this session, and it will get back to you. Does anybody know the answer to this? By the end of the month, we will send you a link to this session. So you can take notes, but no need to go crazy. And although I did want to do the introduction, I'm not going to. So Jason, I will let you introduce yourself. Sure. And good luck. Enjoy.
Yeah, that's better. Thanks, Pete. So thanks for all coming to this instead of that Amazon Web Services talk. As soon as I saw the schedule, I thought, uh-oh, never want to do that. One time I was competing against Ajax when it was popular, and they had about 500 people, and I had one guy. So it was me and him. Hey, thanks for coming. So this is better than that. We're here to talk about security. I'm going to talk the first part, then I'm going to take the second part. If ever he's going like this while I'm talking, you all let me know, and that means he's going to correct something I'm saying. He's the domain expert, all right? This is hard stuff, right? I find it interesting, though. I guess all you do, too. But it's challenging because security never goes on a box on the architecture. It's kind of everywhere. They draw it on the bottom. They draw it on the side. It encompasses everything. It involves almost every participant in the organization. They have to have their interaction with security, and it's scattered from this system and that system. You don't have one policy, but you have multiple systems. This is hard. We're finding that this operational data hub does make it easier, so we're going to explain what MarkLogic does to make it easier to manage security and the built-in technologies that we have and what the benefit is. A lot of times it's so tricky to do that people say, you know what, I'm going to lock down my network and I'm going to only really secure there. Once you're on the inside, then I'll just trust everything, but I'll block it on the outside. But that doesn't work very well, right? Remember the Equifax breach and how that happened? An Apache Struts bug allows people to get command line access on a web server, and from there, they're able to steal all of our personal details. That should not have happened. But what they did is they just put all the security on the outside, and the moment you could crack that with an Apache Struts bug, then you had all the golden data in the center. We call it the squishy middle on the slide. So we're here to talk about the squishy middle. We should have done that as a slide talk title, the squishy middle. Luckily, MarkLogic brings a lot to bear on securing that squishy middle. And we'll work through kind of all of these steps through this talk. One thing is secure by default. Out of the box, there's no default password. That's just inviting disaster. We've seen other databases do that, right? Sure, it's easy to have maybe an open port at the beginning, but then someone comes along and shows how 20,000 databases are on the internet with their data free. So the first thing we say out of the box is please create a user admin account. We don't even say admin should be the username. Pick something else and create a password. You have to do it. We'll talk about role-based security and how that works, and authentication, authorization. We'll talk about encryption here. We'll talk about redaction and anonymization, and just how security can be a part of the whole life cycle. And I think you saw in the keynote too, the idea of securing your database isn't to lock it down and keep the data from ever being seen. It's to let the people who need to see it, whether it's the person interacting with the application directly or some researcher doing data science against the data. You have to be able to do security in the database, and you have to do the right thing for data sharing. And these days, you want to deploy in the cloud. Everybody's worried, what do I do if I'm deployed on the cloud? How could that possibly be secure? And so we do a lot specifically to make the cloud more secure that we'll talk about later, especially focused on encryption. So let's start with just limiting who can see anything. And for this, let's access documents. Who can see any particular document? What can the user do? And when you do this security stuff, we all see authentication, authorization, and auditing as the big A words, right? Oftentimes people start with authentication, but we're going to start with authorization. Authorization is what's a person supposed to be able to do? What are they supposed to be able to see? What are they supposed to be able to do? And for this, we have roles, compartments, privileges, and permissions. And let me explain this. Security 101. Privileges. What actions you're allowed to do. I always think about, like, can I reboot the server or not? And honestly, I get confused sometimes with permissions and privileges. So just remember, rebooting the server is not a right, it's a privilege. All right? So now you know which one's which. So whether you can do a thing, whether you can set a cookie, whether you can write to a URI path, whether you can do some verb, that's a privilege. Permissions are on documents, basically. What are you allowed to do with that document? Are you allowed to see it? Are you allowed to change it? If it's code, are you allowed to execute it? Okay? And at the lowest level, we use RBAC, kind of standard industry stuff. I've seen it talked about in other places, role-based access control. The idea being, don't give people permissions and privileges. You give roles permissions and privileges, and then people, when they're logged in, are given roles. So I know who you are, I know your roles, and I know what your role is allowed to do. And that allows you to be squishier later, right? An editor, a manager, these are roles that are allowed to do things. And the person may come and go, but the role persists. And so the database knows mostly about roles. Okay? And graphically, we have roles. They have privileges, what they're allowed to do. There's capabilities on the document. On this document, we have role 1 is allowed to read. Role 2 is allowed to do a node update. And so depending on the user, if they're role 1, they're allowed to see this document. If they're role 2, ironically, it's possible not to be able to see it, but to be able to change it. And it makes some sense, like think auditing. Want to be able to add something. Okay? And RBAC's pretty straightforward. The normal stuff is pretty straightforward. You come in, here we have a compliance role and a call center role, and we have some users that are part of those roles, and we have a document, an insurance policy. If you're in compliance, you're allowed to read or update it. If you're in the call center, you're only allowed to read it. And so both of these users, these hypothetical users, can see this document. One of them is allowed to update it. Okay? Basic stuff. You insert a document. You say, these are the roles that are allowed to do these things. You got to be careful, by the way, if you insert documents and you don't give yourself the ability to see them, you're going to be like, MarkLogic does not load any documents. I mean, I've been there, right? You're sitting there going, I loaded 1,000 documents and I don't see them. What's wrong with MarkLogic? And the answer is nothing's wrong with MarkLogic. You just loaded documents and didn't give yourself the ability to see them, so it's hiding them from you as part of good security policy. Oops. There is a really cool thing, compartment security. I don't know if any of you have used this. In this case, it's a little bit more complicated. So I have some US insurance policies and some UK insurance policies, and I've done a compartment of a country. And so then the US insurance policies, you have to be able to see them because of your call center role, but you also have to be in the US. Not allowed to see it in a different country. And then the UK ones, you have to be in the UK. So the top call center person can only see the one document. The bottom call center person can only see the other document because of the compartment security on it. And this was added originally just for government customers, but now we see it kind of more widely used. And it's a very powerful feature. So you can create these compartments. In this case, country is the compartment, and you have to have some aspect of that compartment to be able to see it, and it ends with the other things. So normal security is, you have to have a path to it. With this one, you have to have the specific access via that compartment. He's still nodding, so I'm still doing good. Like, he's literally nodding. All right, good job, Jason, good job. All right, it gets kind of cooler still by going inside documents. So maybe you have some documents that have some personally identifying information, some health information. We see this all the time. How do you do that, and how do you do this at speed? So the idea is that we've added MarkLogic 8, element level security. And with this,
initial version came out in
you're not allowed to talk. It causes problems. He did it to you. The idea of this was that you can, at the element level, say this thing has some different security than the rest of the document. That's pretty powerful stuff, right? So it always was at the document level. People would often ask for this, and we gave an honest answer of, the granularity is at the document because it's just inefficient to do it much smaller. And really, for a while, engineering didn't know how to solve this, to do it at scale. Because think of the challenge. You're going to do a search. Just think of a regular search. And as part of that, I have to know about every little part of every document that you're allowed to see, and it might be in a document that you're not allowed to see. Maybe on this one it's in a document you are allowed to see, but in an element you're not allowed to see. How could you possibly do that? And then engineering actually figured it out in MarkLogic 8. And I'm not going to explain it here. Catch me later. It's pretty cool, this role set concept. The reification of role sets was how it's done. But when they did that, it's as fast as anything else. It is as fast as document level. It's not done after the fact. It's not done as a post-filter phase. It's out of the indexes. And you get to define who's allowed to see which parts of documents. And so here's an example. Social security numbers, you got to be in the HR role to read that. So if you look at the document, you're just not going to see that element. We're not going to say we suppressed it. It's just going to be like it never existed to you unless you're in HR. That's pretty cool. But it can get fancier. And this other one matches the access attribute with USA. So you have to have the USA role to read any reg that matches in its attribute the text USA. Whoa, that's pretty wild. But that's done at index time. So it's still really fast. Or in this other one, we have a top secret role with update privileges. So any data classified as in the attribute of top secret, you have to have that role to be able to update it. All done out of indexes. Pretty cool, pretty amazing stuff that they did this. So feel free to use this in certain situations. The idea is, this is different than redaction that we'll talk about a little later. The idea is that this just hides from any user with those roles. Like that data is not there even when they do a query. So this is a more robust version of the full security, right? The roles have privileges, they have capabilities of what they're allowed to see, but then there's also this protected path aspect to it. So whether I'm allowed to see the secret data here depends on am I allowed to see the document and am I allowed to see the element that it's in. And it could be any arbitrary path. All that's in there, okay? So that's the basic security model. Element level, RBAC, element level security going down. The next thing we'll talk about is proving that you're you. Right? So now I know who's supposed to be able to see and do what, but I need some way to know who the user is. So we'll talk about that. There's local and external authentication. With the external, there's LDAP and Kerberos. I've had these for maybe since 8 as well. And now SAML 2.0. I'm actually excited about SAML. Does anyone know about SAML? This is good stuff. I'll explain. And certificate-based that we won't talk in too much detail. So we recommend, when possible, that you do external authentication, which means that you keep your master list of humans not in MarkLogic. You keep it in a Active Directory with LDAP access, Kerberos, something like that. Mostly just because then it integrates with your enterprise system, right? You don't want to necessarily have to duplicate the users of your enterprise again in MarkLogic and synchronize them. I mean, we do it. I've done it. Just you run a regular job to synchronize, but it's so much nicer when you can do the external call. I did that before we had this feature. When you do that, LDAP works pretty well for Active Directory. Kerberos I see used for people who are logging in. I'll talk about SAML, and certificate is where a client certificate identifies the user. It's real easy. The one thing to remember, the roles, because the roles are given those privileges and permissions, those do have to exist in MarkLogic. So the list of humans is external, but the list of roles, that there's a manager, that there's a director, that there's a president, those kind of things, those do have to be in the database. All right? And then how you map humans to those roles can be external, meaning that like a group from LDAP can say this person's in this group, therefore they're in these roles, or that can be done internally where we know who the person is and we keep some mapping of persons to roles. We also have a database inside MarkLogic. I think we've all used that. That's where your admin user goes. In general, we recommend you basically just keep that Bootstrap admin account if possible and make the other humans external. You need that admin account because if the external location changes, you won't have any permissions to update the link, right? So be careful of that. You ready for SAML? Why am I excited? Because of this challenge right here that I'm about to explain. We like a middle tier sometimes, right? What is a good way to do security with a middle tier? Because things like LDAP tend to be where MarkLogic, when you talk to MarkLogic, it can talk externally. When there's a middle tier, there's another player in this game. So what's the right way to do security when we've got a middle tier involved? And one way is that you present your credentials to the middle tier, and the middle tier forwards them to MarkLogic. thereby MarkLogic being able to do the external authentication as needed. It works. You see it done. Do security on the wire, of course, please. Be careful what you're logging. But the downside is that both the middle tier and MarkLogic could be password collectors, right? A bad written application could catch the passwords that are flying by, and that's not ideal. So, okay, not great. What else could you do? The middle tier can just hit MarkLogic with a very powerful user and say, run this as so-and-so. I have verified that this person is so-and-so. Here are my credentials proving that I am the master of the database. Please do what I say. Okay, kind of gets the job done. What's the downside of that, right? Well, some bad middle tier gets to do whatever they want, right? If you can, in a government situation, compromise a developer on the middle tier, they can steal everything, right? That's not necessarily what you want. So what you'd maybe prefer is have the client present a secure token to the middle tier that the middle tier can pass on, proving who the person is, but without any credentials involved in it, right? So the token gives identity with some proof, and then MarkLogic is able to independently verify that the request has come from a user. They have short time spans, so a bad middle tier might have a small window to try to do something nefarious, but the token's good for a very short amount of time. This is what SAML is. Okay? And it's also kind of Kerberos, right? Same idea. He's still nodding, so I'm doing great. So what is SAML? Security Assertion Markup Language. It's just this type of token where you can assert some security aspect. It's generated by an identity provider, which is, think of it as an SSO server. So instead of passing credentials to your MarkLogic stack, you pass your credentials to an SSO server, which gives you the token, which then you can present in. And due to some shared secret between the MarkLogic stack and the SSO server, you're able to verify this is a real token generated by the SSO server. Okay? And so in a three-tier application, the middle tier today is doing the generation of the token and passes it to MarkLogic. What MarkLogic's job is, starting in 909, so this is fresh stuff. So even the people who follow MarkLogic closely are probably learning something now. In 909, we can read SAML 2.0 tokens and respect what they say and verify that it's a legit token. And that we can map those attributes that are inside of the SAML token to the roles that a user has. And I like this because this solves my middle tier conundrum. I don't like giving the middle tier some superpower password or credentials to the database. I don't like passing passwords all over the place. I much prefer this because the passwords are never seen by anybody on the MarkLogic stack, middle tier included. Yet we're verifying that the user actually is the user. So SAML's good. He's still nodding. All right, so let's talk about sharing information outside the database. This comes up because you have PII, personally identifying information, or PHI, personal health information. I want to give data to data scientists. I want to create realistic data for UA or UAT or for a MarkLogic sales demo. Sometimes I've had to do this, like let's load real data over there and then we'll do this process so I can give to a developer some fake data to deal with. The challenge is, I don't want to have that real data in it. So I need a way to identify what the data is, and I need something to suppress it, scramble it, manipulate it so that it's no longer useful. Okay? And so what we do, what MarkLogic has as a core capability, is to redact at the level of elements, properties, or some free text patterns. So if something looks like a phone number, for example. Okay? And then we give some built-in rules and functions that can manipulate the data. Let's quiz you. What do you suppose concealing does? It's not there. We just don't pass that on. Random. Make up something. What's your phone number? Random number. So instead of suppress, I'll give you a phone number. It's just going to be total gibberish every time. I'll make it up random. Deterministic.
Always the same value?
Always the same value for the same input. The idea being, I want to do some data science, so every time this person's name appears here, here, or here, it should map to the same thing so I can associate. I don't know who it really is, but I need it to go to the same thing over and over. I'll talk a little bit more about that later. Dictionary. Like deterministic, but I want more control, right? So Jason always becomes Bob because I said so. And that's how I want it to do it. Pattern, that's like phone numbers, what the pattern is. And custom, of course, we give you your own ability to do your own thing. So if you want to do something special. So here's an example. The original content on the left. A BI export, we're just suppressing the PII. Phone number, actually phone number's changed. Customer ID is manipulated, probably random. Social security number suppressed. Address, mainline gone. City, state persisted. Zip code persisted. So some are manipulated, some are suppressed. Right? The QA dev one, similar. We're doing a customer ID that's random. We've got the name persisted, the phone number's the same always. The SSN has been suppressed except the last 4 digits. The address line is there because we need the address line there for the code to work, but it's just total side street now. We're making it up. And some of the rest has been manipulated lightly too. Okay? So redaction is the process of going from that original to different versions with important data removed. And the way it works, at the lowest level, there's a redact function. And this function allows you to test, basically. So you can play around in the query console, and you can throw some data through it, and you can say, validate my rules to make sure my rules are good, and then run a redaction, and you can see, oh yeah, I see how this works. How you use it for real is the second line of code with mlcp, DMSDK and mlcp. You pass -redaction my rules, and my rules is a collection, and this collection is a set of rules. So you pass a collection name, we go to that collection, we find the set of rules, and we will apply all the code in those rules on your data. So now what you get on an export from MLCP or DMSDK is the data with the redaction rules applied, therefore the PII removed. Okay? That's powerful, and just about everybody out there doing anything with personal data needs this ability. So here's some code example. This is a JSON declaration of a rule. My description is random. My path is policy client ID. So that's the thing that needs to be redacted. I'm going to do a mask random on it. And there's some options for each of the functions. This one, a length of 10. So I want some random data, 10 digits long. And then I insert this with a document insert. There's the JSON name, doesn't really matter. The JSON node as the second argument, and then the collection I'm putting it in. And by putting it in that collection, when I invoke it with MLCP, it will be applied. So it's kind of a half tutorial, half explanation, right? So now you're ready to do redaction. It comes out of the box. I think this is cool because I'm a nerd. Anyone know what salt is? Yeah? Right. So you want it deterministic so that the given name always goes to the same thing. But the problem is if we all do that, then someone can create a lookup table throwing all the possible inputs. They'd figure out all the possible outputs, and they could reverse it. It's kind of a rainbow table attack, just like passwords, right? So you add salt, and it's kind of like a password, but it's not. It's added to the deterministic nature of it. So if I give 3 people this thing with 1 salt, they could compare notes. And a user X becomes the same user Y in all of them. But if I give someone else a dump with a different salt, the breakage, the determinism is gone, basically. It's deterministic within that domain, but it's broken across domains, which is pretty cool. But then, extend salt. What is that? Eh? Got nothing. This one took a while. We argued about it, actually, right? This is really neat. It's because we don't trust you enough. What it means is that, well, 2 people might do the same salt, just because you're lazy. Like, salt might be a very common salt. So there's an extend salt, which is also added. In the collection, it's also the collection name. You can also do a cluster. That's another attribute, in which case the cluster ID and the salt are used to make the deterministic process. And someone else using the same salt on a different cluster would not get the same output. All right? So I kind of joke that it's, for people who wrongly use the same salt, acknowledged. For people who wrongly use the same salt when they didn't mean to, we add an extra bit of salt. So that's the extend salt. Since we're running short. Auditing. You want to track what people are doing. We have that built in. Your application can also do it itself. This is good for tracking things. I'm going to move fast because she's giving me the 5 minutes. Advanced security. Is my data secure on disk? Can a cloud person see what my data is? Can someone manipulate the data? Can I, if I'm a bad actor, go back in time and erase what happened? The solution to this stuff is encryption. With encryption, you can keep people from seeing what they're not supposed to because even the sysadmin can't directly see the data. You can do better governance because someone can't manipulate the data on disk. Otherwise, I could create, it's a bank account, let me just give myself $1 million. If I know the file format, boom, I'm a millionaire. And easier compliance too because I have to be able to prove to the regulators that this is not possible. So it provides the two things, the confidentiality and the integrity. Confidentiality, no one's allowed to see. Integrity, you're not allowed to change. Okay? I think we're all following along. Let's talk about the details. There's two ways of doing this with internal and external key management systems. Internal means that we have a wallet that knows the keys to the files, and we maintain it within the MarkLogic system. This is the default. It comes out of the box, able to do this, and it works. It's not the most secure. I'll explain in a minute the most secure, but it works pretty well. You need the wallet to decrypt the data. If you've got all this data there, but you manage to get rid of the wallet, the data is useless to you because all the keys to unlock the data are in the wallet. And you need to have the admin password to be able to see the wallet or a separate wallet password. Okay? This kind of, it's great, actually. We give this as core part of the product. And it works fast. It's on the Intel chip. And the Intel chip now, I mean, this stuff used to be, what, 30% of an overhead? Now it's like 3%, right?
Single digits.
Yeah, single-digit percent. So these days, thank you to Intel, we can encrypt without incurring a big cost. We use AES-256, and your code doesn't know the difference, with or without. We do recommend, though, in security-conscious environments, that you have an external key management system. With this, the keys aren't on the MarkLogic system. They're on a dedicated hardware device external. And every time MarkLogic is needing to do some key work, it goes to that external system for the keys. It's like a mother may I. In which case, the DBA is weaker in this environment because the DBA doesn't have full domain. They have to participate with the security officer who's running the KMS. Here's my analogy. In the old days with a building, if you were a trusted employee, they'd give you the physical key, and you could come to the door every morning and open or lock it down at night, right? That's like an internal wallet. You kind of give the person the full set of keys. This is more like the access badge. Every time you do something, beep, am I allowed in? Well, it goes off to the KMS in the world and decides if my key is still good, right? Anytime it doesn't work, you're worried you got fired. But, uh-oh. But that's how it should be, right? Every time here it doesn't work, maybe the KMS decided your cluster shut down. And the external KMS can make your data completely useless the moment that it stops giving the decryption support for your database. So that's external KMS. One last bit on backups. When you do backups, there's really three kinds of ways to do it when you're doing encryption. One is, I'm going to specify a passphrase for my backup. This is good if you're going to hand it to someone else. And then you give them the key separately, right? Here's the data, here's the key. And they can restore with that key. If you're doing something just within your cluster, you can use a cluster level key. That's good for restoring into the same cluster, but you couldn't restore it anywhere else because it needs the wallet for that cluster. It leaves the keys in the wallet. So the backup doesn't have an ability to self-decrypt. That's good for security, right? Or you can do it with an external KMS backup key encryption key, which is I need the external KMS to be a part of any restore. Okay, so there's these three kinds of backups. One is self-contained backup, and I'll give you a password, the way you'd think about it. The other ones use the wallets. And if you're using these external KMSs, these are 5 vendors that we do a lot of work with to make sure that it's going to work well with your MarkLogic deployment. It's actually only 3 companies because the same company bought up the top 3. It's called a monopoly. And then one just quick thing. If you're doing HADR, you're probably going to have a key management system on both sides. Okay? And you're going to have different keys. Because you don't want them talking over the network to each other. You want them talking to their local KMS. Okay? And then she's telling me I'm done, and it's my last slide. Nailed it. So one thing to just be aware of. There is an advanced security option with MarkLogic, and these are the 3 aspects to it. So now you can kind of understand what we mean when we say there's an advanced security option. You get the external key management, so that ability to go to the external KMS, the redaction capability, and compartment security. Those are the 3 parts of advanced security. And Rangan will cover everything about the Data Hub service and security. Should I nod over here?
Good. Hi, everyone. So let's take a look at what the Data Hub service is. You heard in the keynote presentation about the MarkLogic 10 release. You heard about the Data Hub Framework 5.0 release. And then you heard about the Data Hub service. Right? So I'll talk a little bit about the service architecture from a security perspective. So I'm not going to cover the nitty-gritty details as to how it is architected. But from a security perspective, what is it that we do in the Data Hub service to secure your service offering? Okay. So it's up or next? Okay. So here you go. So the DHS, as we call it, or the Data Hub service, has 3 top-level roles from a customer perspective. So there's an account admin, who is the first person who bootstraps the service account. So if you've gone to mlsvc.marklogic.com, which is the entry point for the service offering, you will create your first account associated with your AWS account that you should have for using the service. And then that account becomes the account admin. We expect them to have full access the first time around. The reason why I say that is this is the bootstrapping account. The first person always gets full access. And then the account admin is able to create the user who can then assign the security admin to himself and also assign and delegate the service admin to another user. So hopefully by the time the service is up and running, you will have an account admin, a security admin, and a service admin. These roles are implemented such that you have a clear separation of responsibilities between these 3 roles. The first, we expect the security admin potentially to go and revoke the security admin privilege from the account admin, because our account admin doesn't need to be a security admin. Right? As long as the security admin, there are at least 2 people with that role, you will be able to revoke anybody else's security admin access, including the account admin. Okay? But we need at least 2 people. The service admin is the person who actually controls the service. He can configure the service. He can deploy code to the service. The code is actual application that you guys write to run on the Data Hub service. So when you instantiate an instance of the Data Hub service, we have a set of predefined roles. In security, one of the key things to remember is the less knobs you have to tweak, the less mistakes that you'll make. And if you make a mistake in security, the implications could be unforeseen. You may not realize what you're doing till it's too late. So we provide you with a set of pre-canned roles. So these are the roles that we predefine. And these currently are the set of roles that we feel is required and sufficient for the service to be operational and functional. You are allowed to create custom roles on top of these roles, but those roles will have to inherit all the sets of permissions from these predefined roles. In a regular on-prem deployment, you were able to go and create any role with any privilege, any access. In this, you are relatively restricted to a stricter security model. So how does all this work? So I told you a little bit earlier about how you provision an account in the DHS service, and you need to have an AWS account. The AWS account is your account that you own, in which your services that are going to be developed runs in your environment. So we manage the service for you. You manage all the identities and the applications that you develop in your dev and test environments. And then you can actually use them in our environment. In order to use that, you need to be able to communicate, upload, and do everything into the DHS service. How do you do that? You need connectivity between the 2 accounts. VPC is the way to provision that access to our service. So you would set this up as part of the setup process. So when you set up a service, you would configure it, and then you set up networking, and then you're ready to go. So this is at a very high level what the architecture looks like. The sign-up process is through the portal, which is the entry point to the cluster. We have a monitoring service that's done by the ops director. You might be familiar with the ops director application. We use that internally. So we have the customer environment, which is the VPC to peering to the service. You can have more than one service. Every time you create one, you will need to peer it to your environment. So you can see that there are multiple service accounts. Each service instance is a MarkLogic cluster. Okay. And it's elastic. So it grows and shrinks. So you might have seen in the initial keynote, there was a slider bar, which allowed you to set the MCUs. So, and you also saw the graph where the load was elastic and the cost went up and down depending on the time of the day. So this is what makes it scalable. We scale in and out depending on how your load is and what your search criteria is. On the left-hand side, you have LDAP, IAM, HSM, and KMS. So these are the components we use to secure all of the key material and the entities that we need to secure from a security perspective. And just to give you a high-level overview, this environment is the one that we are looking to certify independently. So you're assured that this is run as per the standards that are set by NIST, and including FedRAMP and a bunch of other industry-accepted standards. Okay. So that is where we need all of these components to be able to secure the cloud offering. In an on-prem deployment, you would have your LDAP, where your users would be, or an IAM, which is an identity and access management. You might have a KMS or a HSM, but we are going to be deploying all of that in the service environment. So we can manage all the keys for you. Okay, so I talked a little bit about certifications. We are in the process of getting SOC 2 Type 2 as our first certification. We are in the process of getting NIST 853. That is the baseline for pretty much all of the certifications, including HIPAA, FinServ certifications, as well as FedRAMP Moderate and High. So we plan to get that very soon. And the key thing about certifications is there is a multi-level approval process. So what we get is what is known as attestations, which means the deployment and the configuration as well as the usage is managed and monitored and attested by an independent third-party certification authority. In the federal space, for FedRAMP, we get what is known as a sponsor, and they come in and take our attestation and certify the whole environment. So right now, this is available in the commercial AWS cloud. We plan to offer this in the Azure environment as well very soon. We plan to also, at some point in time, make this available in the C2S environment for the GovCloud. Okay, this was the last slide. Now that you have, you know how secure the GitHub service is, please go ahead and sign up, and you can try it out and let us know. Okay, so one last slide. I would like to let you know that there are a bunch of white papers that we have written. What are the top concerns for integrating data? When you heard a lot about the data hub bringing various data elements together into the data hub, what are the kinds of criteria that you need to keep in mind when you bring data from disparate sources into the data hub? So this goes through some of that. We have some white papers on how you want to build security into your MarkLogic thought process and architecture, how to develop securely on MarkLogic. So there are some guidelines as to what you need to keep in mind. And then once you're done, how do you deploy this thing in your environment? This currently is focused on on-prem deployment. We hope to have white papers for this and for the cloud as well pretty soon.
Thank you, gentlemen. I appreciate it.
Okay.
So, do we have questions?
So we are opening up for Q&A.
Did you see that was did the mic get turned off? Does anybody have any questions? Oh, here we go.
This is complex stuff, so if you don't, we did our job wrong.
So implementation-wise, how is role-based security different from compartment security?
Implementation-wise, well, compartment still uses roles.
So
Compartment, one way to think about compartment is that there may be a secret that you have to have multiple different avenues of not like. Am I dead? I'm good. Oh. We're back. So one way to think about it, so there's a spy whose communication is via satellite program. And you're not supposed to know about the spy, and you're not supposed to know about the satellite program. But some people know about both of those things, in which case they can know what the spy just said. But if you only know about the spy and not the satellite program, you shouldn't know the data. If you only know about the satellite program and not the spy, you shouldn't know the data. You need to know about both of them. That's a good example of compartment, whereas the typical role-based is, I need to get there via this, or this, or this. Any paths allow me to see the data. This is more restricted in that this data is compartmentalized, and you have to be able to access through every compartment. Okay, so there can be like 2 different compartments here, and I have to be a part of both compartments to be able to see that precious secret. Does that help answer?
So you create a role for every possible scenario?
No, you create compartments. Think about compartments like countries, and so then this data is seen by these 3 countries, and this data is seen by these 5 countries. And so then if there's a country compartment on this data, you better have a country that's appropriate for the encoding of that document.
Perhaps an easier way to think of it. Most roles is on an or basis.
Right.
You have either that one or that one or that one. Compartments, it's and. I have to have that and that type of thing.
Yeah. That's how it was first described, yeah. You have to have an or within a compartment, but an and between them. Told you I'm a nerd.
You have another one back there, or are you adding? No. Come on, you have a question?
So on the Data Hub service, there's a service admin role, right, for inserting and updating documents and things like that. How does that interact with the LDAP roles for users?
Okay. So the service admin role, let me go back to the slide. Okay, so the service admin role, as we have specified here, can manage the service, deploy the code, right? Load the docs and run the flows. So that's part of the service administration. The users, on the next slide, we have the flow developer, right? Who actually is the person who develops the flows. And then you have the flow operator, who is the user of the flow that was developed by the flow developer, right? And then we have various other roles, the endpoint developer, the endpoint operator, and endpoint user, which is the regular user. How do you map all of these roles to an identity? If you look at the architecture diagram here, you see the customer LDAP, and you see the endpoint user, the app developer, and all of those roles. The users are there in the customer LDAP. Okay? In the portal, when you set up the service admin can go and map the DNs of those users for those roles. That is how that mapping happens. So when the user comes in and authenticates, we look at that mapping, and that's the role we assign to that user.
Other questions?
So you are encrypting and decrypting the data, right? Using the keys. So how to secure those keys?
Okay, so are you talking about the internal KMS or the external KMS?
External KMS.
Okay, so the way external KMS works is, let me go back to that slide. Okay, so in the external KMS, what we have is whenever we create or want to write anything in the MarkLogic database, the internal workings of advanced encryption is like this. We generate a key, which is a symmetric key, which as per AES 256, right? And then we use that key to encrypt the data. We take that key, and when you set up the external KMS, you have to set up 3 identifiers of the keys that are generated, maintained, managed by the external KMS. MarkLogic doesn't have access to those keys. All it has is the ID of the key that it knows exists someplace else. So once the MarkLogic is done encrypting the data, it sends that particular symmetric key with that ID to the KMS. KMS encrypts it with the actual encryption key, what we call as the DKK, data key encryption key. And that's an envelope. It sends that envelope back to us, and we store that as part of the file in the first few bytes. And then the encrypted data. So when you open up that file, we read the envelope, figure out that, hey, the ID here is external. We try to contact the KMS. We ask it to unenvelope it. It does it because it can decrypt it and it has the key. Sends us back the decryption key, right? Which is actually the encryption key that we use to encrypt the data. So we use that to decrypt the file and then present the data. See, one thing you need to keep in mind with encryption is there are 2 things you need to keep in mind. One, if there is a data set that needs to be decrypted so that the search can be completed, we have to load that entire content into memory. Okay. So everything has to be decrypted and available in memory. So that's something that you might want to keep in mind, because we cannot do a search unless the entire thing is available in memory.
Yeah.
What is the role of admin here?
The security admin?
Yes.
The security admin's role is to actually manage the external key. This is not the MarkLogic security admin. This is the KMS security admin.
More of an enterprise one.
Yeah.
So MarkLogic makes a file, invents a symmetric key, encrypts the file, tosses the key to the KMS. The KMS delivers it back enveloped. And then that envelope is put at the head of the file saying, if you ever need to read this, this is going to be your secret to it. So then later on, MarkLogic has to get the key back, because it immediately forgets about the key it used to make the file. Right? Hands it to the KMS and then forgets it. Then later on, you've got a file on disk encrypted. It says, well, I know the key's inside this envelope, but I need the KMS to crack the envelope and give it back to me to be able to read the file. And that's what those external keys are doing.
There was one more question over here, I thought, or didn't.
The reason for the 3 is because there's config logs and data. And so you may have the right to see logs, but not data. And so when we do it, we say, hey, this is a data key, so encrypt it with the data envelope. And if it's a log file, then we'll say this is a log one, so envelope it with the log one. And so then depending later on when we say, hey, this is a log one, if the person should be able to see logs, then please decrypt this for me, otherwise don't let them. But it's all controlled. The decision's always on the external key. We did include encryption out of the box for free with the local wallet. So we want everyone's data secure, but the external key is better for enterprise. You have a question in the back? No?
Terrific. Thank you both very much.
Thank you.
Thank you all for coming. There's this break going on right now, and then after that is our fireside chat in the amphitheater. So join us then. And again, thank you all for coming.